Hello interwebs, welcome to Let's Fix Computers. I've got a 2015 MacBook Pro here, so it's a Retina era, or the end of the Retina era, and this laptop is stone dead, doesn't turn on. So let's take a look at this and see what the matter is. I'm going to plug in the Paul Daniels meter with a USB Type-C to MagSafe 2 adapter. We'll just have a look at what the Type-C meter tells us about it. So as you can see, we've got about 30 milliamp. Well, it's bouncing between 20 and 30 milliamps of current draw. Just see if it'll turn on or do anything. So yeah, nothing going on there. That bouncing current though, that looks like a pulse to me. That looks like, oh yeah, there you go. Did you see that current spike? So I saw this earlier on when I plugged it in just to do a quick assessment. That little spike there, that to me looks like something in the laptop is shorted and it is doing it's power cycling effectively. So it's not actually powering up, but the standby rails are power cycling. So let's open this thing up and we'll have a look and we'll see if we can figure out what's wrong with it. So I'll roll the intro while I take out the screws and we'll take a look inside. Alright, so inside this laptop, we're on the original battery by the looks of things. It's getting on a bit, this laptop. You know, 2015, it's starting to, it's 8 years old, but they're still perfectly viable, these things. Their biggest weak point is that they don't support a lot of modern video decoding techniques, which is the interesting part. They seem fairly zippy, but as soon as you're watching, like, if you have like a Twitch stream or if you have a Twitch stream or YouTube open and you're trying to do something else at the same time, it's amazing how easy it is to just load down the CPU on this. It just doesn't seem to do any decoding in graphics anymore. It just does it all on CPU, which, yeah, as I say, they can be surprisingly loaded with surprisingly simple tasks. But other than that, they're still fast to use. This thing should have 8 gigs of RAM. It's probably got a 256 gig SSD there, so, it's fine, basically. So I'll disconnect the battery, and I'm just going to have a quick look around. I can't see anything screamingly wrong with it. I think what we're going to do is we're going to start going through, based on that power draw from the power meter, I think we're going to have a short circuit somewhere in here. So I'm going to try buzzing out some rails, see if we can find something that's shorted. So I'll spin this around. Okay, so let's start taking some basic measurements from this laptop. I've unplugged the battery and we've put the multimeter into resistance mode, and we're just going to check if any of the rails are reading low resistance first, because it looks like we probably have a short somewhere. So if we start checking rails, we should find one that is looking bad. So we've got these. I've got the schematics open here in Flex Board View. This is an 8204924. And we're going to start off with the basics. So we're going to start off with PP3V42 and PPBus G3 hot. So PP3V42 is the first 3-volt rail that powers the SMC, the charger light, and stuff like that. This is almost certainly going to be okay because we had a light on the charger, and you can't get a light on the charger without PP3V42. So, but we'll check it anyway. So PP3V42 underscore G3 hot. So the G3 hot bit, G3H, that means this is an always hot rail, which means as long as there is power to the laptop, this rail has power. So if the battery is connected or the charger is connected, this rail is on, basically. So there's a spot on top of the board here that I can measure this from, down here next to this resistor and capacitor, and we'll start doing some zapping. If we find anything interesting, I'll bring in the microscope and give you a close-up view of it. So with my black probe on a screw hole for ground, let's just probe that guy there. 48, 47 kilo ohms, high resistance. That's fine. No problems there. All right, what about PPBus G3 hot? PPBus. PPBus can be measured from that current sense resistor there. 98 kilo ohms, 95 kilo ohms, lots of kilo ohms. Again, not shorted, so PP bus is fine as well. All right, let's start checking secondary rails, so 5 volt and 3 volt rails. So these rails have multiple stages. We start off as S5. So when the laptop gets power from the battery or the charger, PP bus G3, the hot rails, so PP bus G3 hot and PP3V42 are instantly powered up. They are powered directly from the charger or the battery. Then those rails, or PP bus G3 hot rather, will then power the S5 rails. Then the S5 rails power S4, S4 powers S3, and then once you've got S3, you can then go to S0, which is main power on. So we need to start at the S5 rails. So let's find the 5 volt rail. So PP5V S5. PP5V S5. And I'm lazy, I don't want to take the motherboard out yet, so there's a tiny test point there that we can check. So that's next to this big inductor here. So black probe on ground, stab, 12 kilo ohms. So again, no short circuit there, lots of kilo ohms. We're looking for like 0. We're looking for less, you know, like we're looking for less than 5 ohms for something that's vaguely suspicious right now. Like proper, complete, catastrophically low resistance. Fine. All right, what about 3v3 S5? PP3v3 S5. That is available over here. Let's check that. 2 kilo ohms. That's fine. All right, so our S5 rails are okay. I'm going to jump straight to the S3 rails and see if we're getting that far. So let's just change that to an S3. PP3V3 S3. Oh, that's all on the bottom of the board. Is there a test point? No. Okay, we'll come back to that one. What about PP5VS3? Can we get to that without taking the board out? Yes, we can. Yeah, that's the inductor for PP5VS3. That's that big inductor there, nice and easy. So let's check that. So this is next to that test point that we just checked. That one. Wah, wah. There we go. Now that's a short circuit. So that's less than an ohm. So that's what we want to see. Okay, so PP5VS3 is shorted. So the 5 volt standby rail is shorted. Now, so this is probably, since the 3 volt rail looked okay, although we haven't checked P3V3S3 because it's on the other side of the board. But what I'm going to do is, when you've got a shorted 5 volt rail on one of these, the last time we saw this was a shorted USB port. It was actually on this I/O board over here. And I found that I've seen it before, and when I checked that, there were a lot of people in the comments that were just like, oh yeah, I've seen that before, that's a common one. So I'm going to try a quick pot shot and just disconnect the I/O board and just see if we come good. So let's take this guy off. Oop. Whoops. That standoff has come off of the board. Be still. Okay, that's not a problem. It's just a cover plate. If this standoff was for like a CPU hold down or something like that, I would be worried about that. Not super fussed about that. It's just a hold down plate to stop these popping off. Let's bend that back. So this cable here, this is carrying 5 volt and 3 volt over to the I/O board. So I'm going to disconnect this, and we're going to see if our short circuit is on the logic board side or the I/O board side. Right, let's check again. And our survey says... There we go. Kilo ohms and rising. So let's check the pinout for this, because it looks like our short circuit is on this board somewhere. And I bet money it's going to be that USB port again, because we've seen that before. So let's pull out from the schematic and go over to this connector here. So here we've got PP3V3S4 and PP5BS3. So the bottom two connectors are ground. So I'm going to put my my black probe on a screw hole on the I/O board now, and we'll start stabbing these. So we should have ground. Yep. Then ground again. Yep. Then 3V3S4. Mega ohms, so lots of resistance there. And 5VS3. And there's our short again. Okay. So the I/O board is shorted. So at this point, if I unplug this I/O board, the laptop should power up. So let's just put that to the test. So we do need the battery connected for this board to power up. So I'll connect the battery, open the laptop, and the fan won't spin when we turn this laptop on. When it's cold, the fan doesn't spin. So I'm going to plug in my CMI Zapper Chipmunk, which makes it nice and easy to tell if the board is powered up or not. And we'll plug in some power. Okay, and straight away on the Paul Daniels meter, you can see that we're getting 600 milliamps. So that's doing something. The laptop has powered on, and that green flashing light there, that means there's activity on the USB port. So that tells us the laptop is turned on. There we go. We do actually have a picture as well. Lovely. Okay, right, let's get this board out and see if we can fix it. So this looks like it's going to be the same playbook as the last time I saw this. There's probably a dead capacitor on this board around that USB port is going to be my guess. So let's pull this out and see if we can find it. This is kind of neat because the last time I saw this problem, I had already taken the laptop to bits. So now we get to do the whole thing from the beginning. Alright, looks like there's a fair bit of grot on this board. Let's put it under the microscope and see if we can spot our culprit. Alright, so lots of grot here. What I might do, I think it's going to be one of these guys. Like, that guy looks sketchy as hell. Is that a crack? I don't think so, but maybe. What I think I'm going to do is just brush this down and then see what I can determine. So let me just come out for a brushy a moment. Oh yeah, no. Yeah, that guy looks sketchy as hell. Like, these guys are different colors and stuff, but that's par for the course for capacitors. Some of them look lighter and darker than the others, but that guy looks like it's cooked. There's no crack in it or anything. Let's try and get up on the other side of it. It's not cracked, but from the top, you can kind of see that weird indentation on the top. That's certainly where my money is. So let's start by checking if that's actually on the shorted rail first. So once again, multimeter in resistance mode, and we'll just check if that's actually shorted. Black probe on the screw hole. Oops. That's not shorted. That's ground on that side. That's open circuit though. Yeah, no. There we go. All that talk about that guy looking sketchy, it's fine. That's not it. Okay, what about these guys? Alright, now that is shorted. I think last time it was one of these guys. So this is all a ground plane here. So they're ground on that side, and this is going to be the 5-volt rail. And this is like a... this is the 5-volt regulator for the USB port or something like that. We'll check it in a moment just as an interest thing. And it's got all these bypass caps. So like any of these bypass caps could be suspect as well. But these two would be my suspects. So yeah, I always, like, every time I remove a bad capacitor, there's someone in the comments that's just like, oh, I saw that right away. And I'm like, what do you think, guys? Which one of those looks like the faulty one? Place your bets. Okay, so let's turn on the hot air station at 400 degrees, maximum airflow. And I'm going to grab my tweezers. And we're just going to pluck off... I mean, I'll take both of the... I think it's going to be one of these two. So I'll take both of them off and we'll measure them both. Here we go. Oh no, I've got no nozzle. So I'm going to place these on the sticky tape, and now when I try and measure them, they won't ping off into the shadow realm. Be silent, multimeter. Okay, right. Candidate number 1. Ugh. That seems to be high resistance. Yeah, that's just open circuit. We can probably get a read on that if I go to capacitance mode. That's a 20 microfarad capacitor, which sounds about right. Candidate number 2. Oh, wah, wah, wah. That's not shorted either. That's a 10 microfarad. Slightly down on capacitance, but good enough. Alright, so we've got a 10 and a 20 microfarad capacitor. Neither of those has failed. It's not them. It's something else here. And just for posterity, if we... let's just check our rail again. We're going to find that we're still shorted. Whoop. Yeah, we're still shorted. It was neither of them. Okay, fine. So, that tiny guy there, if you look very carefully, you can see that it's not on the same pad. So that's not it. So moving back along, we've got something here. And then we've got all these bypass boys. So, they're all dead flat. So this I/O board isn't on the board view, but it is on the schematic. So in order to find where it is in the schematic, what I'll do is I'll look at this chip here that we're working around. And that's got 2557 on it. Texas Instruments 2557. So let's just try searching for that. There we go. Right USB port A, USB port power switch. So the problem we have here is that because we don't have the board view for any of these sections, this doesn't actually tell me anything useful. So what I think I'm going to do instead is just inject onto the rail and see what gets hot. Because we can be fairly cavalier here because this is a 15-pound part, basically. I said this in the previous video where I repaired one of these, that we could just replace the board for minimal expense, but while we're here, we'll see if we can fix it. So in that case, what I'm going to do is I'm going to get my power supply and my thermal camera, and we'll just quickly stab it and we'll see what heats up. So I've got a fairly small board here, so I'm going to hook up a crocodile clip to one of the ground ports and then stab it with a probe. So we'll connect the ground to there. And I'm going to inject at 1 volt and 2 amps. No need to go mad. Because we've got a thermal camera, we don't need a huge amount of power for this. Right, power supply is on. And I'm going to stab the rail where we saw the short circuit. And I'm going to try and do it in such a way where I'm not covering up everything. So look for the light. There we go. Bing. Right, who's that? That's one of those big bypass caps. Right, let me get you guys a close-up of that. So there's that stack of capacitors, and I'll just touch the rail again. Bam. So it's the top one. So it's the top one closest to the HDMI port. Nice and clear. So that's that guy there, everyone. So let's take that off the board, and we'll see if that's cleared our short circuit. Right, I'm going to take off 2 of these capacitors because I want to measure one of them. And these caps don't like the heat, so I kind of want to be fairly decisive here. Right, and so firstly, we should now find that our short is gone because we've removed the cap that we identified as being shorted. Oh, let's just come off of my improvised soldering mat here. Black probe on ground, and there we go. So our short is now gone. We've got high resistance on that USB power rail. So this will now technically function now. So what about these resistors? Where's my tactical tape? Alright, that's our shorted guy. And this one is high resistance. So if we go up to capacitance mode now, we should be able to get a read on this. 43 microfarads? Yeah, I think that's a valid number. Right, so it's a 43 microfarad capacitor, and it's on a 5 volt rail, so it needs to be rated for, you know, at least 5 volts. So probably like 6.3 volts or something like that, I think is the nearest round number. Well, I say round. The nearest classification number that I'm aware of. So these capacitors are kind of oddball size. See, the problem is, because capacitors are not precise, it's hard to know what the actual rating of that is supposed to be. And annoyingly, it's not actually on the schematic that I can find anyway. We've got our USB power switch here, but the capacitors are upstream of this rail here. Although that says 68 there. Does that mean page 68? There it is. So I don't know why that doesn't appear when we search for it. However, this comes directly from PP5V S3 reg, so this doesn't actually help us. We're not going to find that anywhere. So we've got a bit of a bind here where we can't find the component we're looking for in the schematic. It might be in there somewhere. Considering everything else on this board is, I find it hard to believe that it's not in there, but I'm not sure how to find it. And even if I do find it, that will then lead into the next problem, which is I think the only place I'm going to find another one of these capacitors is just on another one of these boards, which means I may as well replace the board. So what I'm actually going to do in this instance is I'm just not going to replace it. I'm going to put the working capacitors back on here, and we're just going to send it. We've got a bank of these capacitors here, and what they're doing, they're providing just a bank of power. So when you plug a high power device into the USB port, there is a reservoir of power that can just suddenly go ugh to power that device up, and it stops it from pulling down that rail when there's that initial inrush of something being connected to the USB port. So this has to keep in mind that USB ports, they're not that high power, but there's a lot of high power things you could plug into them. You could plug in a external hard drive, or you could plug in a phone to charge, or something like that. And so that's what they're kind of engineering to avoid. But that's not something that actually happens that often. And if it does, it's going to be fine, because bypass capacitors are generally fairly over-spec'd. I have a policy of replacing components whenever I possibly can. I think it's good practice. In both like just making sure you've completed the job, and also just understanding how to do the job right. Because while not every capacitor needs to be replaced, but if you practice replacing capacitors, when the time comes around that capacitor is critical, you're going to have more experience on how to find the correct one and replace it. A lot of the time when people find dead capacitors on boards like this, they'll just rip it off and send it. And by and large, that's probably okay. You know, that's generally fine. But it's good practice to replace components when you can. Knowing my luck, as soon as I post this video, someone is going to go, it's on this page, and I'm going to be like, but there it is. It be that way. Right, I'm going to drop under the microscope, and I'm going to put some fresh solder onto these pads and just flow these capacitors back on, except for the dead one. It doesn't particularly matter which way round these two go. I'm not sure which way round they were previously, but they're parallel, so it makes no difference. Come back. My airflow's a little bit too high, but if we warm up, we'll be okay. There we go. That's you guys. And that's you. You're going to need a reflow because there's way too much solder there. Okay. Right, I'm going to find the alcohol and clean that up. Oh, that cap's terrible. I'll hit that with the soldering iron in a sec. Alright, let's put this back in the laptop and then we're basically done. This was a bit of an unnecessary adventure, all things considered. So, you know, like I said this the last time I fixed one of these. You can buy these on eBay for like, you know, 10 or 15 pounds, probably 10 or 15 dollars kind of thing. So they're not really worth fixing as such. But I've said before as well that this kind of thing is good practice. It's testing for fault finding and dealing with faults when you find them. And being able to do that practice on a slightly less critical area of the laptop is also always a good thing. So I'm going to bully this back into place where it doesn't want to go, apparently. There we go. Right, I'm pretty confident about this because we did a test while we were diagnosing, so I'm going to go ahead and put the back cover on as well. I'm going to live dangerously. Right, I've got the laptop started up, and to test the USB port, just to make sure it's happy without that capacitor there, I'm going to plug in an external hard drive, which I think is probably the highest realistic load this USB port is going to see. There's probably some examples of higher draw devices or like higher burst draw devices, but I don't know. I think an external hard drive where it's got to spin up the mechanical disk is pretty hardcore for a USB port. So I've got a USB meter here. So let's plug that in first. Alright, so we've got our 5 volts, no amps, and I'm now just going to plug this in, and we should just see a burst of current, and then it'll settle after the disk spins up. There we go. I definitely saw 600 plus there, so it was probably a bit higher on a peak. And now the disk has spooled up, it's settled down at 200 milliamps. Good, so that's us done, everyone. So as I said earlier on, probably easier to just buy a new I/O board if you're actually doing this repair. However, good to practice on stuff, and also just goes to show how sometimes very simple problems can make a laptop look stone dead. So just remember your stabbing techniques. Remember, check those secondary rails. It's something that I don't talk about in repair very often, and I'm trying to get into the habit that when I start diagnosing logic boards, we go through those secondary rails, because I really should be doing it more often. Anyway, thank you everyone for tuning in. Hope that was interesting, and I'll see you next time. Bye.